Hello friends, and today we will be discussing about Python libraries. I've seen various questions on what are Python libraries, famous Python libraries in data science. So this is just a video to help you clear your doubts about libraries and libraries especially in Python. So what is library? Let's just move on to understanding what is library. So I would say library is a collection of reusable chunk of codes, and they can be included in your programs or projects. Okay, and I would say that they are a collection of core modules. When you use in your program, you don't have to rewrite the code again and again. And so I would say that they eliminate the need of writing code from scratch. Okay, now there are over 100,000 libraries in Python. So that means that you have the liberty and the freedom to use libraries at your own wishes, depending on the need of your project. So that's what we are coming on to now, that they are useful in developing data science, machine learning, deep learning projects, image processing projects, applications, and also data visualization projects and applications, right? So I think library is a little bit sorted, that they are a collection of reusable chunks of code which would help you to eliminate the need of writing code, and you can use it as and when you need. And it is a lot easier to use these libraries because they have really made our life so easy. So now let's come on to deep learning libraries. Okay, so when deep learning comes, the first thing that stuck my mind is TensorFlow. So I will talk about TensorFlow. So TensorFlow was developed by Google. It was Google Brain team that developed TensorFlow, and then it was made open, to public. So it was an open source library now. It is fast, reliable, flexible, efficient. But it is good for beginners. But later on, when you start using sessions and placeholders, things might get a little complicated. Okay. Um, the comparison between PyTorch and TensorFlow has been done in one video, and you can see that video. Now I come to PyTorch. PyTorch was developed by Facebook. Now I would say that this is a competitor of Google. So PyTorch, Facebook came up with PyTorch. Again, it is an open source library, and this is useful for computer vision and NLP tasks, right? Okay. So these are the deep learning libraries. If you want to deploy your models for deep learning, either use TensorFlow or PyTorch. But there are other libraries also for deep learning, and they are, okay, I'll talk about Theano. Theano is the basic library, and this is the math library. It is helpful for numeric computation. And one interesting fact is that TensorFlow uses Theano at its backend. It just wraps the Theano functions, the maths, every complex computation that is happening, Theano is doing it for TensorFlow. Okay. Another thing is, I'll tell you about MaxNet. Now, this is developed by Apache. You can train and deploy your deep learning models, and this supports various languages like C++, Julia, R, and that's why it is really, really very popular and demand with commercial giants. Amazon uses it. Google, Intel, they use this MXNet. And now I come to other libraries, and in that you've got other deep learning libraries are Cafe, FastAI, CNTK. Now, since there are many libraries, how would you decide which library to use in your project? So I would say get your hands dirty with various libraries, various packages, so that you can decide it for yourself, depending on the demand of your project and assignment, which library you want to use. Every library is being developed, community support is there, and they are, by with time, they are just evolving. So I cannot say that one library is superior over the other, but yes, widely used libraries are TensorFlow, PyTorch, CNTK, and I can say MXNet. So use it. I've used TensorFlow and PyTorch, which are good. TensorFlow is for production ready, if you want deployment production ready, and PyTorch is basically for research work. And TensorFlow has various functions and features and utilities, which I have covered in a video. It will be provided in the end screen or in this card, you can say. So you can go ahead and see that, okay? So now we come on to our machine learning libraries. Okay, so I'll come on to machine learning libraries. So what are these machine learning libraries? The first of all which comes is NumPy. This is the basic backbone of machine learning, guys. NumPy deals with your mathematical operations, linear algebra, arrays, matrices, tensors, you name it, and you have it in NumPy if it is mathematical. TensorFlow uses NumPy at its backend to do all the calculations. So NumPy is used everywhere. This is indispensable. The second is SciPy. SciPy. It's called SciPy. SciPy. Okay. Yeah. So this is used for scientific and mathematical tasks, and this is again built on NumPy extension. So a lot of bits of pieces of code were being clubbed together, and so they were being clubbed together to form this SciPy. Okay, for your statistical and mathematical task. Next is scikit-learn. I would say scikit-learn is a logical development, because once you had NumPy and SciPy, very strong, robust libraries, the next logical conclusion was scikit-learn. What happened? It is built on two powerful Python libraries, as I said, NumPy and SciPy. And there are various algorithms which this scikit-learn supports. So there are various packages which we import in our projects, which supports supervised machine learning, unsupervised machine learning tasks. It has classification, regression, clustering, dimensionality reduction. All these packages are there in this library. You just have to call them and start working. So this is really very powerful. Now, one thing I want to tell you about is pandas. Okay, since I cannot get data manipulation and analysis library as a separate category, so I just included other libraries like pandas. This is again very important, and pandas we use for our data analysis and manipulation task in a project. If you have to deal with data frames, you have to deal with data structures, you have to convert a table, a column, you have to perform various operations in that, and it's just like you are dealing with numerical tables. But pandas is very useful when it comes to time series. Yes, pandas was being developed keeping in mind the time series analysis, and you see the forecasting, you see when you're predicting the prices, when you're using the time series forecasting, anything that deals with time, pandas really is a boom, and it really helps. So pandas complete course, I'm coming up, it will be launched in January. So, and all the important functions, operations of pandas will be covered in that, especially time series, because pandas specialization is time series. Rest we use it for our data analysis and manipulation purposes also. So now let's move on to something. Okay, image processing libraries. Okay, image processing libraries. What are image processing libraries? Now, since now we are entering into the domain of artificial intelligence, computer vision. Okay, so now we have scikit-learn, scikit-image. So again, this is an open source library, and now this includes several algorithms for image segmentation, geometrical transformations. You manipulate with the image, the color space, the filtering, the morphology, feature detection, and whatnot you can do with that image. So scikit-learn provides you with all those packages, and it is way lot easier to manipulate with those images, guys. Really, it is very useful for beginners, intermediate or advanced level, whichever level you are at. Just use these libraries and you are like on the same platform like anyone else. Next is PIL, or it is also called Pillow. This is Python imaging library. Now, again, what you can do, you can open, manipulate, save images, again, work around, play with those images. So we import PIL, and I think I have done a video on that. How do you import an image with using PIL? So I'll provide link in the description box, also in the end screen. All right. But there are many image processing libraries which I'll be coming now to. Okay, I'll talk about OpenCV. Now, this OpenCV, if I talk about, okay, I want to show you OpenCV. So this is again open source computer vision library, and it is mainly aimed at real-time computer vision. Now, this was originally developed by Intel, and this has got some over 2500 algorithms, optimized algorithms, which you can directly use it in your code. And this what it is used for, it detect, recognize faces, you can stitch images together, you can identify objects, you can classify the human actions in videos, you can track camera movements, you can also track the moving objects, extract 3D models of objects. So it gives you a lot more flexibility in processing an image, stitching your image together, understand the movements which is happening in an image. When you record a video, you can simply extract it into chunks and pieces and understand in detail at what really happened. So it's very useful when you are using it in fraud detection, or in a CCTV footage you have captured some theft or something like that. So OpenCV, yes. Now I have got another library here, and that is called Simple CV. Now this provides a concise, readable interface for cameras, image manipulation features, extraction, and format conversion. Okay, I have now I want to say something here, that I've simply copied it from a website. But I just want to tell you something practical thing here. Like, what is the difference between OpenCV and Simple CV? All these libraries we have dealt with are aiming the same purpose: image processing, manipulation, saving the image, working with that image. Now, what makes a library more powerful is the community support. Community is the backbone for all these open source libraries, because when community supports, they help in the code enhancement, its evolution, adding more features, removing features, debugging, and so many things that a community can do together. So it's like united we stand. So this for OpenCV, for TensorFlow, for PyTorch, or you can say for scikit-learn, the community support is immense. For Python altogether, the community is really supporting and helping you to bring out robust libraries for all of us to use and get familiar with machine learning. So Simple CV community support, the forums, they are not that active. And I found that once you start working with Open Simple CV, you are stuck somewhere. You have to switch on to some other image processing libraries in Python, so that you can just go on working for it. Okay, so the continuity of a library, community support, the popularity, all supports whether that library is really powerful or not. Okay, so all libraries are doing great, but what depends is that how in a longer run that library really sustains itself through community support, through robust usage. And yes, okay, so now we come on to different yes, data visualization libraries. Now this is my favorite, and I have done a series of videos, tutorials, and a separate playlist is dedicated for each library. Please go and watch it. I have done a lot of effort for that, and I will provide the link in the description box. Okay, now we move on to Matplotlib. So what happens is that in Matplotlib, this is the most popular data visualization library. And I can say that this is used for 2D plotting. Okay. And this is most widely used library for plotting, and it is more than a decade old. So this is really powerful library when I talk in terms of Matplotlib, right? So more than a decade old, and this is we have used various features of Matplotlib, plotted various plots, pie plot, histograms, and whatnot, scatter plots. And tutorial is there. I won't be going into depth for that. So now we come to other libraries, and now we work on to, okay, I'll take you to Plotly. Now, this is my favorite, Plotly. This is a very interactive graphing library, and I have worked with Plotly projects, and this really gives you a lot of freedom to work with various visualizations. It's very interactive, and I can say this is an online graphing analytics and statistics tool, because it helps you to publish your work online also. And you can work with various languages like Python, R, MATLAB, Perl, Julia, or REST and other languages here, right? Okay, so now I move on to a different library, and that is Seaborn. Seaborn is again another, it is built on Matplotlib. This is another robust library, and this provides a high-level interface because this is more advanced than Matplotlib. And it is a logical conclusion that now you're adding more features on Seaborn to make it more visually expressive, right? And it aims to make visualization center part of exploring and understanding data. And you can really understand your data well. So I walk you through Altair. So what this Altair means, this is a statistical visualization library, and this is a declarative library, if I say that. because it is declarative, because you don't have to worry about how the data will be presented. It will be presented, it will be taken care by default by Altair. So I say it is based on powerful Vega-like visualization grammar, and that's why it is I'd say it is a high level, it uses high level API. It is based on this Vega Lite visualization grammar. So get your hands dirty with Altair, understand it a little bit. But if I have an inclination, I will bend towards Plotly, Matplotlib. And Altair, it's okay, but yes, when I have Plotly, by Altair. So now I move on to ggplot. Okay, so now just like ggplot2 is for R, ggplot2 is for Python. It has been inspired by ggplot2. Actually, this is a graphing library used in R, and I say GG, it stands for grammar of graphics. So this grammar of graphics for R, it was inspired by, like, let's go in a little history of it. It was inspired by a book called Statistics in Computing, written by Mr. Wilkinson. And on that, this ggplot2 library came for statistical visualization in R. And this is a very powerful library, a very declarative and a very, very interactive library. You've got all plots can be plotted in a various manners. And ggplot in Python has been inspired by this ggplot2, which is in R plotting library. Okay. So now I move on to end part of this data visualization libraries. Guys, I've got also a course. If you want to get a hands-on experience on these data visualization libraries, there's a course on Udemy. It is priced at the lowest that Udemy can offer, and I could also offer. So the link will be provided. Go ahead and just skim through the course. If you like it, enroll in that course. I would be happy to see you aboard, and we'll be working together. Any comments, any doubt, any ideas about any other project, do let me know, because we are working together as a team. And I hope this was informative video. Python libraries covered, entire libraries, the most important libraries which we really use in a day-to-day project and assignment. So I think this was it for this video, and thanks for watching.